the share or something. All right. So we're doing a code walkthrough of the beta version of the GitLab extension today. All right, so I have your suggested topics in my notes, and I'll take whatever notes we make and I'll expand them and add them into the docs folder when it's up there. So we
Sure,
can kind of
sure.
continue to build our documentation up.
Yep, yep.
All right, so I'm gonna go ahead and I'm gonna share my Visual Studio. Oh, all right. You able to see my screen okay?
Yep, yep, it looks great. Are you on a different screen now?
I changed the size so it would work better for you.
Okay, awesome. Thanks.
Yeah. um, okay, so the code organization here. So we have the top level project GitLab extension, which is built into the extension. And then we have a test project that has the unit tests. And then I have things broken up mostly into folders. So we have the code suggestions folder. And this is the integration into Visual Studio and the logic that like shows and accepts completions.
Okay.
And then we have the language server, and this is all the stuff for communicating to the language server, starting its process, etc. And so some components and code suggestions use some of the components in language server to like start a language server client, which then in turn starts the process up and so on. And then we have, I'm going to skip down to settings util. This is where we have stuff around the like the GitLab options inside tools options. And it's
Okay.
also where we have the routines for storing data in the registry, and also a single class with a singleton instance that can be used across the code for accessing those values.
Okay.
And then we have status, and this is the code around the status bar.
Nice.
And so, there's more than one entry point for Visual Studio. There's some in a few of these places. So for example, in code suggestions, we have a GitLab proposal source provider. And this is an interaction point with Visual Studio. So how it kind of works is as our extension loads up, we export some special interfaced classes that then get recognized by Visual Studio, and then it'll call into them. And so, for example, this one provides a proposal source provider, and proposals is basically their version of ghost text. And so this ends up just returning an instance of this GitLab proposal source, which is where all the real logic is for doing the interactions. But this is our entry point from Visual Studio. And so at some point during the process, we'll get a call to this Git proposal source async. At which point I'm gonna like start up. I'm gonna make sure our logging is configured. We'll make sure the status bar is initialized, and we'll return an instance of our proposal source, and then we'll start up a language server client. Which the reason we do it kind of early is this is going to start the process, and so we want to make sure that gets just started as early as possible, so that when someone actually wants a code completion, we don't have a long turnaround time getting all this stuff configured.
Gotcha.
So when you find these, these interface points, there's usually very little code in them. Really all we're doing is returning an instance of something else most of the time. So that's one of the interface points. There's also an interface point in, excuse me, the language server. We have an LS Visual Studio package here. And this one, it gets exported a little bit differently. Here you'll see this package registration artifact or attribute. And then this will also get called up during a load. And for this, we're really just, this is our way of understanding if a solution is opening or closing. It allows us to take some actions in the language server, like, restart it with a new project or solution, stop it when we're closing a solution. And so there's a couple of functions in here. This one has a little more logic, because this is where we're going to kind of handle opening and closing solutions. And we'll go ahead and we'll try and preemptively do this really quick. So the purpose of this is, if you were to close a solution and open one, you want to make sure that we start a language server really fast. And the reason we have to start a language server is we pass in the solution name and solution path as startup environmental variables for the language server. And so if our solution changes, we have to restart the language server or we'll have the wrong context.
Okay.
I know it's a little bit strange.
Well, this sounds important.
Yeah, although I feel like there must be I didn't really look for this, but there must be an LSP way of saying that, which would be nicer to not have to restart things. And then we also restart things if like someone changes a setting that could be important to language server, like a GitLab URL or the token gets changed. We'll restart it as well, because those all get passed in as well as environmental variables we set when we start it. Okay, so that's another interaction point. And then let's see. And then in settings, we have GitLab options package. And this is another one that gets another entry point from Visual Studio. This one happens when someone goes to the tools option page. Then this will get called, and this is what's going to drive showing the settings, these special attributes here.
Okay.
And extending from dialog page. So if we wanted to change the description for something, you'd do it right here. And if we needed to add a new exposed setting, you would have to edit this file and add another property here.
Is
and then
that
update the load
description
and save.
is that description for the access token accurate?
It is not. That's a good point. We should update that.
Okay.
There's my to-do list for today. Yeah, because that stuff changed recently. All right. So, and then taskbar does not have an entry point. So those are the entry points that we have right now. And then we want to talk about entry points to the LSP. All those entry points are going to be in language server. And primarily it's going to be process manager, which will handle starting and stopping the language server and guaranteeing that it closes when you close Visual Studio. So I've found that we don't always get the open and close solution messages if you're like terminating the process or doing other things. So one of the things we have in here is this child process tracker, which it's a weird name. What it's going to do is it's going to link the language server process to the Visual Studio process, such that when the Visual Studio process goes away, the language server process would also go away. This is kind of like a fail-safe. If someone goes into like Task Manager and like hard closes the app, and it doesn't call any of its cleanup code, then
Right.
we won't get a dangling process, which is really nice. So the main entry point though in the language server code, pardon me, is ls client. So this is the component that's called by code suggestions to do stuff. And then ls client is going to call the process manager to start the process. And then it's going to start an RPC session with the language server itself. And so if we come in here, let's just look at the functions in here. We'll have things like, we have a start language server, which will go ahead and call the process manager to start things up. We have when the settings change, if certain settings change, then we restart the language server. Connect async is kind of the public API that would start everything off. So you'll see in the code suggestions code, there'll be a call to connect async, and this in turn will go through and make sure that we're configured, make sure we don't already have a client that we're connected to. If to avoid kind of like a fast amount of restarts, like if language server is broken or erroring all the time, what I have is an exponential back off to starting the process. And we also have like a, pardon me, a maximum retry count. So we won't continuously sit there trying to start new language servers over and over and over again. And then here's where we'd start the language server off if it needs to get started. And then here's where we're going to create our TCP client and connect it over the TCP port. And eventually we'll change this to just use the standard in, standard out. And then here's the RPC connection point. So this JSON RPC attach is going to take the stream, and it's also going to take an instance of our ls client RPC. And ls client RPC is where we have functions the language server can call on us. So for example, there's a diagnostic endpoint the language server can call if there's an error. We don't really do anything with that information now. Since we often, the important errors often cause a JSON RPC error. Like it won't go through the open, the LSP method. It'll just be returned as an exception in the JSON RPC. For example, if you hit like the 403, where if your access token has the wrong scopes, then we'll get an exception out of JSON RPC. We won't get the call our helper function there. And then so like right now the client LSP RPC is really simple. The only thing that I've seen them try and call is this publish diagnostics, which is the kind of error reporting feature, I think. And so we'll log that out so we have the diagnostic information, but we don't really do anything with it right now.
Okay.
And so once we're connected to the JSON RPC and we have a handler for disconnected events, we're going to send the LSP initialize message. And all of those messages we have that we send are prefixed with send. So we have like send initialize, send did open, send did change, and then send completion request. So it's pretty easy to find where we're doing LSP stuff. And so initialize is largely discarded by the current language server. The settings I put in here don't seem to have much of any effect. Like the language server code is very, very simple. It's an experiment. So eventually I imagine that these things will be taken into account, I hope, by the TypeScript one. But the only thing that is used, there is one thing that's used in this initialize, is I've added support to language server to pick up this client info and add it into the user agent string. So if you had to change, if there was a request to change any of the user agent stuff that we provide, you do that here. And what we're providing right now is the name of our extension, the extension version, and then I'm also sticking in like the architecture information, the Visual Studio version, and the OS version into that string. So we have a fair bit of data going on each request. Oh yeah, and here's where we also provide solution name and solution path to the language server. So it doesn't have to be, like it shouldn't have to be a startup parameter, but it is right now. And
Okay.
then here's where we actually go and invoke that and send the message. This is building up the parameters we're going to pass, and then we go ahead and send it. And so for the LSP protocol, if you ever have to do work there, it'd be good to review the spec a bit. They have basically the idea of calling something that's going to have a return value and sending a one-way message, which is a notification. And so this invoke is for something that's going to return data to us. And so here's where we're getting the result, which is the data being sent from the LSP back to us. Now, in theory, we should be able to look at that and understand some of how the language server is going to work. But we'll need to add some better support for that. Right now, we're not really looking at that and making decisions because it doesn't look like they're populating too much from the language server side.
Sure.
So
Sure.
that'd be something that we'd want to improve in the future. And one of the things we'd want to improve with this, one of the things that would be interesting to do is, so when we send the change message to change, which is like someone typed a character, it can happen almost on every character. And there's two options. One is to give a delta, like here's the cursor position, here's the text. And the other one is to provide the entire file. And the current implementation of the Golang server wants the entire file. And that's something that in theory you
Oh,
can, yeah, which makes it silly. Even sillier, they don't even use it anymore. One of the newer updates, they actually go to the file system and try and read the file, which is not what they should be doing. So one thing that I would like to be able to do is look at the initialized result and decide which method of sending a change we should do. Because I'm pretty sure as the TypeScript one advances, they're just going to keep, they should be reading stuff off disk. They should be keeping a view of all the files in memory or, cache to disk, as opposed to trying to find them on the local file system, which is, I think, an anti-pattern for the LSP. So it'd be nice for the the messages we are sending to understand, which ones are, like understand what we should be doing for those when there's options. Now, once this method completes, we will be connected and like have a proper LSP protocol session started up with the server. From here, we will see the main things that will come back. Methods will get called from the integration with this is going to be like send document did open. So we send this when the document gets opened. This doesn't do anything on the language server side yet, or right now. It's basically largely discarded. We send did change every time we get a buffer change notification. And at one point, this was what they were using to base the suggestions off of, but now they're ignoring what's in here and just going to the file system. And then we have the send completion message. And while these other ones, the send document did change, these are going to be sent as notify messages, notifications. They're one way. And you can see that with this notify prefix on the RPC. Notify as opposed to invoke. And in this one, we'll see there's an invocation going on here. And that means we're going to get something back that might be interesting to us. And so for this, we basically we're just setting like the current cursor position of the file name that we're in. And then on the language server side, they figure out the before and after point based on that. one of the problems I had seen happen um, before they were just going straight to the file to read it. One thing I saw that could happen is would fire off a notify did change message, and then immediately call the send the complete invoke. And there was a bit of a race condition going on how fast the server handled the did change. And there were situations where, um, sometimes the did change wouldn't have been fully processed before we called a completion, and that would result in an error. I mitigated that along with mitigating another issue I'll talk about in a bit by adding a small delay before we send the completion to it. And that seems to work for now. But that might be something that we'll have to worry about in the future. We'll have to see how the TypeScript stuff goes with that. And okay, so that's kind of LS client there. Any questions on that before we move on?
I don't think so.
And I've made a point of trying to document like almost every function in here
Yeah,
under the knowing that
pretty
we're going to hand
helpful.
this off and stuff. So there should be, there should be some maybe not complete documentation, but there's at least some documentation in here.
Yeah.
Client. And then I have here's the back off helper that we use to prevent resource exhaustion by restarting the language server over and over and over again. And this is just a really simple back off helper. So it's an exponential. We have a max retries of 15, which ends up being, I think, 40 minutes or so of retries. They just get longer and longer as you go on. And the default delay between them is 150 milliseconds. So initially we'd be doing retries pretty quick, and then it will get longer and longer.
Right.
For a few of those.
Makes sense.
Talk about child process manager. Models. So I'm kind of moving away from codifying all the models and instead using dynamic object creation to do some of this. Mainly just because there's so many models. Oh, it's ridiculous. Like here's initialize. Like I didn't do every message that you can do for initialize, but it's like 1,000 lines of models right now. But you don't necessarily have to do it this way. One of the things you can do instead is you can just say, new this, and then you can just kind of define, you just type a name equals blah. And so you'll see I've done that on some of the requests. They use hard-coded models, and some of them I've just kind of, created them as I was writing them. Let's see if there's an example of that. So like send initialize string, here I'm instantiating all these objects to build up the message that gets then converted to JSON. That one I did too. There was an example of, I guess for most of these I did that. Somewhere I have an example of doing it differently, but what I want to do is kind of move off like codifying all the models and instead just do a dynamic object instantiation where you can just set all the fields right there and don't have to define all these types. Just because it's faster to do and there's less typing mistakes.
Yeah.
All right, so then let's get into code suggestions. So again, our provider is going to return a proposal source. This is where the meat of everything is. And one of the things we do is we sign up for various like things like buffer changed, and then also so this is implementing a proposal source base. This is the thing from Visual Studio that we're building off of. So, and then there's some functions in that that we implement. For example, We have a create proposal source. This will get called by Visual Studio when it wants to get a proposal from us.
Okay.
So like I often use suggestion and when I write a method call that's ours. And so if you see proposals, oh no, it's request proposal async. So this is the one from Visual Studio. So often when if you see proposal in it, it's going to be something that's coming from Visual Studio versus something that I've written for our code.
Makes
And so as
sense.
we go into this, are you familiar with the disposal, I dispose pattern in C#?
Let's go with no.
No worries. Um, so one of the interfaces that we implement is called the iDisposable pattern, which I think is coming from proposal source. Basically, this pattern is a way of um, of handling cleanup without waiting for the finalizer to get called. Because there's a lot of limitations in how the finalizer can be used. So what we end up doing is there's a special method or methods that we do. Dispose, async, and dispose, depending on the interface you're handling. And this is what drives, I'm sure you're probably familiar with a using statement, where maybe I get like a file stream. Um, and, when you're done with it, it needs to get disposed. And so you use like a using statement. Um, and then, all the code in it will run. But when you drop out of the using statement, it calls dispose on the object. And that cleans up all of its resources. So it doesn't have to wait for its deconstructor to get called. So we make a lot of use of that in our code as well to handle cleanup stuff. And so as we go into a lot of these functions, you'll see that one of the first things we do is check and see if we've already been disposed. We also do a lot of checks to make sure we're configured. And if our suggestions are enabled before doing actions. And then, so here we're going to do the notification. This is where we're going to switch the icon in the status bar to say we're producing we're going to propose a code suggestion. And then we have a finally in here to make sure that we set completed for that. We don't leave it as doing that forever and ever. And so, a lot of times we'll try and make sure we have a license server instance, a client instance. If we don't, we're going to call and create that. And the reason we have to do this here is, if the user has not configured their settings correctly, we won't have a license server yet. And then once they go and do that, we need to get one started. And so some of the entry points we'll try and start one if it's not already there. And this is one of those cases. And then here's where we're going to wait a quarter second. And the reason that one of the reasons there's two reasons that we want to do this wait. One of them is to avoid the race condition with the did change. But one that we also want to do is we want to wait just for the user to finish typing before we start sending code suggestion requests. If we don't have this there and you just start free typing, you're just going to see a continuous scroll of completion requests, like over and over and over again, and they're all getting canceled, and it's like a whole nightmare of log messages. So, like I'm a huge proponent of having like a brief pause before helping the user. One of the things that drives me absolutely bonkers with modern IDEs is they don't do that. And so like as I'm typing, things are popping up and going away, and it's like really hard to see the code I'm writing.
Yeah, absolutely. Is that do
And
you think that's something that should be configurable on the user's end?
um, I don't think so,
Okay.
because one, we need it there for other reasons. Two, I'm just worried that because of how long code suggestions take, users are going to go in there and set this to 0 and then we're going to have like a high load on our APIs. It's going to be, a little bit rougher internally.
Absolutely. Absolutely.
So I
I
would
mean,
say no.
yeah, oh, I guess like let it configurable with the minimum, right? Like 150 is the minimum.
I
Maybe they
see.
want it if
They
they want it
want it longer.
longer.
Yeah, I think if you try, I mean, I'm not sure whether they'd want it longer. I think we're probably pretty good here.
Okay.
The
I
thing
was
is,
just
this isn't
curious.
like a standard thing. Like, it's not a standard thing to be able to configure in modern IDEs, which drives me
Okay.
bonkers. But if it was, I'd be more interested. Like, if there was an immediate reaction when you stopped, like, you're going to stop, and then eventually we're going to come back in like a second with a code suggestion, right? And I feel like that's pretty long time already. So, and then
Okay. Cool.
from there, we're going to make sure we haven't been canceled already, which a lot of times we are, because the user keeps typing. and uh, and then we'll go ahead and say, give us a code suggestion. And then we'll create a proposal collection from the response and send that off. Um, and then for code suggestion, this
Uh,
is the part. Sorry, go ahead.
The was so that it was create proposal collection. So is that going to be returning multiple options? It's just they're just sending one back now, or I mean, because like they talked about, it'd be cool, in the future we want to provide three or whatever. Is that
So we don't try and do that right now, but the code is kind of set up so that we're really quick to do that. Meaning,
yeah, yeah,
like right now, we kind of have it hard coded to only use one, the first suggestion,
sure,
because we don't
sure,
get anything else.
sure,
But
sure,
when we
sure.
change that, this create, like the API we return from this, um, is a collection of proposals. So once we're ready to do that, it would be very quick to change it.
Excellent.
Um, that would probably be a good post issue as well.
Right, but like the LSP needs to support that first, right?
We could add that functionality, and it just wouldn't do anything until
Yeah,
it does support it. Like
yeah,
it'd be better for us to do it ahead of time.
it's true. I guess we could just, like duplicate the suggestions and to like, mock, kind of mock that there's multiples coming through or something. Yeah, yeah. While testing, anyways.
All right, so so now we're in Git code suggestions async, and this is where we actually make a call to the LS client um, to send the code completion request. We pass in, one of the things we do here is we um, figure out our line number and column position, which we pass in. And then when we get our completions back, we look and see if we didn't get any or if the length is 0. And then we'll, you know, pass along any error information that came back, um, along with, putting a nice log message out so we can see that happening. And then like, here's one of the lines that we would change. So like right now we're returning a single collection, insert text. If we wanted to support multiple, we'd make this an array. And then, you know, find all the insert text things there and return them all at once. All right, so next thing probably to look at is we have, one of the things that I'm doing is I'm overwriting Visual Studio's default commit suggestion method and doing our own insertion here. And the reason I'm doing this is in preparation for adding a metric for how many code suggestions we're accepting. This is
Mm,
how we would know that a code suggestion was accepted and which one it was, is by this method here. And right now there's some headers that can be set by the language server. Um, and so once we want to add a metric, we'll have to figure out how to pass that metric along to the language server. What I envision here is we might add a custom message. So the language server supports extending the protocol with messages that would only be, that would be custom and only supported by, like a client that understood them. And so in that format, it's usually like, so with, is if you start the message identifier with a $, then we could do like, GitLab, I don't know, metrics or telemetry or suggestion accepted. And then we could add that to the client and then shoot it off. And then the language server could include it as headers to the code suggestion request. That's how they're picking that up right now. And then anytime a buffer is opened, we'll go ahead and send the did open message. And every time it's changed, we go in and we send the document did change message. And I think that's the major stuff in here. Surprising little amounts of code for doing a lot of this stuff. Okay, so one thing we haven't talked about yet is logging. And so you might see these serial log folders here. So the serial log enricher sensitive is a third-party code base that I've included in ours because the NuGet assembly is not signed. And because ours is signed, you can only reference other signed, like strong named assemblies. And unfortunately, quite a lot of the non-Microsoft third-party extensions are simply not signed because there's some. It's just I don't know. People just don't want to do the work and stuff. And so this is this is a compatible MIT licensed set of code, and this is going to provide us with a way of filtering sensitive data in log messages.
Okay.
And where I'm using that is I have written a masking operation for our GitLab patterns, for our pats. And in the case that happens, we'll just print out glpat -mask or whatever a mask is for this. And it's, like, I feel like this is one of the few, we might want to extend this at some point to do whatever secret detection can capture, to be a little more robust because people might put like AWS creds in here or who knows what. It'd be nice to have those masked in our logs. So that's where that project comes in. And then the other thing I've been working on is I did figure out how to add an extra panel to the output screen. So this in the output window, you have this drop down of these are panels, they get called. And so I've written an extension to Serialog that will add a panel in here called GitLab Extension, and then put all of our debug messages in it. So that it's more, so it's more like VS Code, what VS Code does. And so that code is in here, and it's also very simple. So this would be another interaction point with Visual Studio, although it's us calling into Visual Studio. And when this gets added in, we have a static GUID for the pane we're going to add. The name of the pane. And then when this gets used, it's going to go ahead and it's going to create the pane by getting a service out of Visual Studio, creating the pane, and then getting the pane. And then if that works, then we'll be able to emit messages straight to the output window, which is kind of nice. It makes it a lot easier. And then because of this in the logging, I've also making that trace output that goes to the debug viewer, a debug only build feature. So when we do the release one, we won't be sending all that stuff to the trace, the debug view stuff, which could in theory be picked up by any other application. It's because it's globally accessible. But I'm leaving it in there for us because when I am debugging, I want it to kind of go into a window that's easier to see for me.
Yeah,
Um,
absolutely.
and so for logging, we're using Serilog, super popular logging extension for .NET. Um, and basically when we want to do logging, we configure the logging. We have a lock around this to make sure that we're not getting called from two different threads at the same time. And then we'll go ahead and do a configuration for this. Um, and we're going to log debug and up. Here's where we set up our sensitive data masking with our personal access token masker. Set the minimum level. And then we have a couple of write tos, and this will use the trace sync. And for that, I have a custom output template for what I want to see. And then we also, here's where we pull in our VS output sync. and then we set the logger in the global variable here. And then from wherever you are, you can then you can actually add like log.debug and then like a message there. And this is the stuff I'm working on right now, and I'm probably going to wrap it up either today or tomorrow, having this in at least a first version of it.
Awesome.
All right, let's go into settings util. Talk about this a little bit. So for settings, the way it works is we have the GitLab options stuff, but kind of the core of everything is this settings.cs. And so this is the singleton. This is a singleton. So what we do is we have a private constructor that will set a static property on this class called instance. This is basically like format. This will get improved as we do dependency injection. This will go away, but right now, anywhere in the code base, you can say settings.instance, and you'll get the one instance of our settings back. And that allows you then to check things like, and that comes back as an iSettings interface. And one of the things we do is we hide some of the public access methods on settings behind the iSettings because they're not supposed to be used by people. They're there for our tests to work. And so this interface defines what people can access when they get our instance. This is the main access into it. So we have things like for the GitLab options package, we can say things like start a batch update. So we don't write so one of the things that we do is when you change a setting, we trigger an event. It's like, oh, this setting changed. And so to prevent a lot of churn on that, we have this start batch and stop batch. And when you start a batch, we will turn off sending the event on every change. And then when you say stop, we'll send out one notification that we changed a bunch of settings potentially. And then we have properties for the settings themselves, like access token. Are we enabled? GitLab URL. We also have this helper configured, which tells you if we have enough configuration that we could start a language server. And then we have, and then here's the event that settings have changed. And for this event that we send out, one of the parameters that we pass through the event is going to be the key. We have these static keys, which is the name of the registry entry. And so to indicate which of these we've changed, we'll send back, application name if it's a batch, or access token key, or well, so on. And this allows the person who's monitoring the event to see what was changed and make a decision on how they want to act. So for example, in the language server stuff, we would look for application name, like access token and GitLab token to know if we want to if we need to restart the language server. And then we also have a storage component, this registry storage, that implements, I was just working on some code here, that implements the iSettings storage interface. And the reason that we have this abstraction is for testing. I need to make sure we can mock various things for testing purposes. The other abstraction we have in here is we have abstraction around protect and unprotect. So Microsoft has a really nice, like traditionally storing secrets, there's always this problem of like, well, if I'm going to encrypt it, what do I do with the encryption key? Type of thing. So Microsoft introduced the data protection API many, many years ago that solved that problem by using the user's authentication credentials, basically like your who you are, to do the protection. And so calling protect will, without a key, encrypt some data that can only then be decrypted by that user. And so when we're storing like access token in the registry, we run it through the data protection API so that it's stored encrypted. Now, one of the reasons we have to have this abstraction around it is the CI pipeline that builds all this doesn't provide access to the DAPI. We get access denied trying to call it for some reason. And so when we're running our tests, I have a mock of settings protect that basically doesn't do anything. So we can get around those errors on the CI pipeline area. And then here's the registry storage that implements the iSettings interface. And this is just going to store data in the registry. And so And so as we go into like load and save, you'll see us opening up the keys and loading the settings. Now, one of the things I did to make the transition from the POC over more reasonable is I have a function where, if we don't have the current registry key, we'll try and load the legacy POC registry information. So at least we can pull over your access token and other settings from there. And then we'll do that once and then delete the key if we were able to do that. And then we'll go down and load all the settings from the registry. So if we don't do the load POC, we'll go down and actually load everything from the registry here. And here's where you'll see call to unprotect. So this is what's going to take the encrypted access token and then decrypt it into a legitimate string for us to use. And then we have save, which is just going to try and create the key if it doesn't already exist. And then we're going to go ahead and set all of our values here. And so if you had to add a new setting, one of the things you'd have to do is add it into here to make sure it loads. And you'd only add it to the save and load functions. You wouldn't add it to the legacy registry load since it wouldn't have existed then. And then for bools, we store those as D words. There's no concept of a Boolean operator for the registry. We just do 1 and 0 as those. And let's see, what else do we have? Here's the implementation of the protect, just a protect and unprotect. And this is really simple. It's just calling out to the protect data API to either protect or unprotect that. And the things we're protecting need to be bytes, so we're getting the actual bytes that are being to protection. And there's a scope we can set, which is set to current user, which I think is appropriate. So all users of the Windows box would have their own settings with encryption towards their account. All right. Does that all make sense? Any questions?
Yeah, that makes sense. Yeah, could see problems if it wasn't scoped to the user.
All right, let's talk about status bar. So status bar has two main components. We have this XAML is the, have you ever done any WPF programming?
No,
Okay.
no.
So this is our custom control for the status icon. So Visual Studio is like all this UI and stuff is all C#. That's all using a UI component set called WPF. And basically it's like built around XML.
Mm-hmm.
So you have the visual designer up here, and then here's the XML down below. And then behind that, there's a CS file in here, which has the code on top of things. And so, it's unlikely you need to make any changes to this. We have icons they're in the right width. And so I don't know there'd be anything to change here, but if you had to do something like add a second icon or, wanted to add some text next to it, then you do that here.
Or we might
And
need to change it to say GitLab Duo code suggestions enabled.
yeah, like I could put this text block in here and say, oh, happy extension day. I don't know. Maybe this is where we put errors. And and then you'll see that showed up right here.
Yeah.
I thought it was pretty enjoyable to do the WPF stuff because you could do it, as XML, as visual, and also as code. Probably more interesting though is the code behind this. And so this initially was written by Visual Studio when you create the control. Um, and this is where we're going to have things like loading the images from the resources into bitmap images. We have the tooltip templates here. So this is the messages that are displayed in different states, or extra information if there's an error that gets displayed. So right now, Visual Studio does have this notifications panel where you can put stuff in. I'm not using this to display any messages right now. Instead, what will happen is if there's an error, this tooltip will get a second line with the error message from this template. So if you're enabled or disabled and an error gets displayed, it'll just be added onto the tooltip. So this is going to handle all the GUI rendering stuff. And then somewhere else we'll add, this is basically control, this component is the control. We added into the container that displays a status bar. And so all these things are in there. Now, if you have to make any real changes to any of this code, there's a great tool that I use. And so I'm going to load up this tool and I'll switch over and show you. It's called Snoop. And what it does is it's basically allows you to snoop on a WPF application and see all the UI components in a tree kind of view. And you can see all the properties for all the components and so on. It's pretty neat. There we go. All right, here, let me switch my display over. So what I did is I loaded up, basically when it comes up, you have the option of like dragging a target for the window you want to snoop. And so I just dragged it over to the Visual Studio instance, and this is what it pops up with after a few seconds. And so this is the WPF view of Visual Studio. And so everything you're seeing here are UI components. And so we start with like a top level application, and then it has, then it has a main window, And then we can see that there's, and then, this is the donor, this is the kind of a top level thing. We can expand this down, and eventually we're going to see status bar panel. And so this is, and what you can't see right now is that in Visual Studio, it highlights the UX that you've selected. So when I selected the status bar panel on my Visual Studio side, it is outlined in red, the status bar.
Nice.
And then we can expand this some more, and we can start. And as you click on these, you'll see the different components in there.
Oh,
Like,
there you go. I saw your Tanuki flash for a second. There we go.
so here's our extension status control in there. And so here's the stack panel you saw defined in that XAML. Here's the button that was in there. Oh yeah, and you can see it kind of pop up the UI piece that we're on too. There's a status bar. Yeah, so it's kind of neat. So this is what I use to figure out, how to find the status bar, different insertion points that I can do. And here's the image. So, starting here, extension status control, this is our custom control that I've inserted into this dock panel. And then, if you were to look at any of these other ones, you'd see, so this is the resharper status icons that resharper inserts. That's the corner pull icon.
Mm.
There's the notifications icon. There's an add a source control. This is the we're doing things icon.
Mm.
And so on. So yeah, it's kind of neat. So if you're having problems with the UI and how it's displaying and you want to dig into it, this is how you debug some of that stuff. Or where you'd find out more information about placing the icon somewhere different, or how much space you'd have, and so on. And so like this is one of the places where I can look and see what the actual size of things are. So for example, here's the actual height right here of our image, the actual width. So I'd use these values to figure out what size PNG to ask for.
Mm-hmm.
We can see the button size is bigger. It's 25 by 23. And so it's just useful to see sizes of stuff. And then we can go up to the status bar and we can see like what its actual size is. Like here's the full width of the window. Here's the full height of stuff. Great. Stop that. And here you can see the red outline is still there from me clicking around.
Oh, yep.
So like, there's our component. So that's also very useful to figure out where you're seeing stuff or not seeing stuff. Right, I'm going to close out Snoop. And I'm making a note to add a link to the Snoop thing for in our list of tools. All right, so that's the control. And then, so this handles, initializing all display, loading our images up. Oh, here we go. Loading our images up. Tooltips we went over. So our images right now are being stored as assembly resources, meaning they're embedded into the DLL. They're not on disk. And this is I think the seems like the best way to handle things because there's less chances of having problems with the layout of the file system and things of that nature. And then we also have like simple methods to status enable, status disable, show error, status loading. So we have a few really basic functions that can get called to do actions on the UI. And then this control is used by our status bar implementation. So this is a singleton as well. So we have an instance, here that gets our status bar to it. So from anywhere in the code, you can say status bar.instance dot, and then any of the public methods on here. When we construct, we don't do anything. And the reason is that we need a UI element from Visual Studio to start with. Largely because a lot of the operations you have to do on the UI have to be done from the UI thread. Like you can't make UI updates from a worker thread. And so if we have, any UI component from WPF, we have a pointer to that, then we can do this thing where we access the dispatcher and we can invoke an action on that thread. And so anytime you see this like UI dispatcher invoked, this is us doing a call to something that needs to be on the UI thread.
Okay. Yeah. Okay.
And so if you're doing stuff around the GUI stuff, one of the things you have to make sure is a lot of times you have to be on the right thread for doing something. And this isn't the only place we do stuff like this. You'll see this in other areas where we're going to call an API that needs to be on the main thread, and we'll have some code to either do this dispatcher thing or some other method for getting onto the correct thread to do work. So this initialize display, this is going to get called from the code suggestions entry point, is where we saw that. And that's a place where we have a UI element we can pass in. And so once we have that, we can come through and initialize that display. We can go ahead and hit our, run our dispatcher. We can find the current application. We can find the dock panel. Basically what we're doing here is we're finding the status bar panel and we are adding our extension control to it. Right here is where we add it. So the control is the component. And this is where we're going to say, where do we want that component to be? And so if we wanted to change where the positioning of our custom component, this is where we would do that. Like if we wanted to try and move it all the way over to the right over here, we could try and do that here. And then we'll clear and then this is where we're going to, this function will look at our settings to see if we're enabled or disabled. This is the thing one of the pieces I had to add when the initial display of the icon didn't show disabled if it was disabled.
Yep.
This is the missing kind of call for that. And then we also sign up, and then we also have handlers for someone clicking on the icon. And here's where we'll look and see if we're enabled and then set us to disabled and change our setting to disabled, which will stop us from doing code suggestions. And then the reverse, we can set to be enabled and enable our extensions, which will cause the language server to get started if it's not already started. And then we have here's where you can call to show an error. There's two ways of showing an error. One is a temporary error that will stay up for like a minute or 30 seconds. Or you can have a persistent error that stays up forever. An example of persistent error would be that you have not completed configuration of your extension, and that would show forever. If we're showing an error from an RPC call, we won't show that forever. We'll just show it for some reasonable amount of time. The user can investigate it, because often, we wouldn't want to permanently show an error that was around rate limiting. And so if there's an error coming back from the API, it'll get cleared. And so here's where we start a timer to clear the temporary error that's being shown. And then here's our clear error, which would get rid of it. This is also so it's going to stop the timer. And then it's also going to check our settings and display the correct enabled or disabled icon. And then here's where we can say where progress is in start. And so we'll switch this to status loading, and we'll start our clear temporary. One of the things that I want to make sure is we don't leave in progress going forever. And so we should have really good handling around, making sure that that doesn't happen. But just in case, we're going to set a timer and say, like, look, if it takes 30 seconds to come back, let's just stop showing it, or whatever the time limit I have in there is.
Gotcha.
And then in our complete, we also stop the state timer, and we do our little, what's the right thing, what's the right state to be in dance. And then here's where we start our temporary timer. 30 seconds is what it's set to right now. And then here's our handler for when it lapses, and we can clear it. We don't auto reset the timer, and then we trigger the timer on and off to make sure it's not continuously triggering for us. And then here we can start. We stop it when needed. And then here's our lapsed handler. So that's pretty, not too complicated.
On the status bar, or like where you have the icon, how did you decide to put it there?
Here.
Yeah.
Honestly, I was thinking I wanted it over here on the right. But when it wasn't instantly able to be on the right, I didn't bother spending a lot of time investigating it. Where Visual Studio tries to stick it, this is where if you were to write a string to the status bar through the status bar API, this is where it would go. This is kind of here's where your extended nonsense can go area. Eventually, I would like to dig into how ReSharper managed to get their icons over here.
Yeah.
And do that as well. Because I think it would be nicer if it was just over with all the other icons here, in my opinion. And then, because the other thing that will happen because it's here is we don't see the full messages that come into this area, which isn't usually a problem, but if we were just to move it, it would be nicer. Also, I worried that if someone else is trying to stick something in here, I haven't tested what happens if I have another extension trying to put something here as well. If they just stack up or if they override each other, like who knows? That'll be something we should test at some point.
Yeah. Yeah. I mean, I can play around with that easy enough. Just like change our extension name or something and install it. Maybe change the icon too. Yeah, I just you pointing out that like the resharper icon is over there on the right. I didn't know if like that's the standard spot for extension icons.
Nope, that's definitely a specialty on their part.
Okay. Okay. Interesting. Tangent, but you use resharper. This code suggestions isn't conflicting with that or anything like that too
Good
badly.
question. It doesn't seem to conflict. Well, so right now I have it disabled because there's like I've been trying to move on to the GitLab licensing server system, but it's giving me
Oh,
problems with my license key that I have not yet spent the time to investigate.
gotcha.
Um, but the stuff that they do, they don't necessarily do ghost text. They mostly do like pop-up suggestions and analyzers and things like that. But yeah, that would be a good thing to test since it's such a popular thing.
Yeah, I mean, it's been a long time, but I was a big fan of ReSharper when I was doing .NET.
Yeah, super nice. I have no idea why Microsoft just hasn't copied everything they do. Like it's kind of absurd. Like there isn't a good way of navigating code. Like things I love was Control T, where then you could just like type in anything, it would find the code for you. and you
You
can't really
can't
do
do that
that
in
here.
you can't do that in
Uh,
vanilla Visual Studio.
I know. It's like, what are you guys thinking? So like the best we get is you can do the solution explorer thing, this control semicolon, but like, it's limited in what it'll find, usually I found. Um,
Hmm.
so yeah, it's not nearly as good. Um, I mean, other things have started getting, I mean, Visual Studio has made a lot of improvements. Um, in fact, many of them very annoying to me. Um, like sometimes when I'm writing code, like if I'm going to call, um, oh, that's a weirdness. There's my code suggestion, but let's say look at that. Like, so that's insane.
It's a lot going on there.
Yeah, and the thing is, it's like you can't get rid of it with one escape. It takes three escapes. Um, Even
Oh,
worse than that, there's they have this feature where they try and figure out if you're doing repetitive things, and then offer to do it for you. Um, and that takes a lot of escapes, a lot of escapes. Like it really messes up my code flow. Um, so this is stuff where it's like if you just had a little bit of a delay, like, or no, let me turn off one of the three windows you're showing to me. Like it's just nuts. But yeah, so then when you add in like a code suggestion on top of all that, it gets kind of crazy. Um,
and that's why you went the ghost text route. Is that what you're saying? Or
oh, I mean the ghost text is just the way to do it. But like, but with all that stuff displaying, it gets really crowded in your display.
I guess so. Like, are there scenarios where like you'd have one or two or three of those pop-ups plus the ghost text displaying?
Yeah, you can definitely get to that point.
Oh,
It can get
joy.
really wonky. Um, in fact, if you read the recent Copilot blog post about, they were talking about for the drop-down list, as you scroll through it, it'll give you different suggestions by adding that contextual information in, which also tells you that that's happened to Copilot. They're getting these things, you know, blocking their stuff too. So I don't know. It's just like it's really kind of drives me batty. This is really why I'd like to have all that stuff behind a small delay. Um, my favorite code editor of all times was called Slick Edit, and all that stuff was customizable. You could have like delays of varying lengths for when it would help you. Oh, it's so nice because then it doesn't interrupt your thought process. I'm not always hitting 500 keys to do everything because even when you
Yeah,
finish writing a line of code, stuff is going to be popping up, and it's like, oh, I just want to do my work. But yeah,
yeah.
so okay, so um, oh, let's talk about app.config. Oh, the joy of assembly binding. Have you ever done assembly binding?
No.
This is for um, when you have different components that want different versions of things. And so you start having to do binds, basically configuration saying, well, map this old version to the new version. And so what will happen is you'll use a third-party component that's compiled against an older version, and then it will complain it can't find that version because the version you're using is a little bit newer. And so this is all areas where I've been mapping various assemblies to older versions to newer versions um, to get things to work. And we have a lot of them in the test as well. So our test project, for some reason, is getting there's some components that want different versions of things. I don't know, it's a whole mess. I'll point this out. If you end up getting errors where it says file not found loading an assembly when you're running tests, this is probably the culprit. Is you probably need to add a an assembly binding redirect. So just
Okay.
letting you know it's there. I know it's awesome. Um, and
Appreciate the
sometimes
heads
when
up.
that happens, I sometimes need to install a specific package to like have a fixed version. Like, because some of this stuff can come out of the MS Core library. But often if I'm having to remap things, what I do is I'll go install the NuGet version of the package. Same version, it just means that now it's going to be shipped with our assembly as opposed to picked up from the underlying.
Hmm.
And that makes it a little easier to do these bindings. Sometimes it's a requirement to do the bindings. Because we do have a different set. We do have this NUnit and NUnit 3 stuff coming in. Um, as well as our project. And so I think at times there's some just, version differences between the assemblies. It's supposed to handle a lot of this by automatic, but it doesn't. um, so that's a good entry into our test system. Um, so we're using NUnit as our test driver. Uh, that there's an adapter um, for running it for having it show up in Visual Studio. So you can use the Visual Studio Test Explorer panel to run these. And then this is the main stuff. Um, and the tests are somewhat limited because we don't yet have a dependency injection set up in here. I wasn't sure what we'd want to have given all the entry points that Visual Studio calls, like when would be configuring that, how it expose it and stuff. Now that I've written the extension, I have a much better idea of how I want to approach doing all that.
Sure.
And once we do that, we'll be able to add more tests. So some of the building components I have in here um, is we have a test data class, and this is this basically contains defaults that we want to use as test data. It also manages saving the existing settings off, and then repopulate them when we're done running tests,
Hmm.
because this is just going to go to the same registry setting. We don't have the ability to change that yet.
Gotcha.
And so, again, if a setting is added to the system, you'd want to come into here. You want to set up a place to hold the setting that we have, um, and also properties to provide whatever the default value or current value we want for that is. And then we have to make sure we update all the places in here that need to set that. Like for example, we have this one-time setup and one-time teardown. So at the very beginning of the world, we're going to detect if we're in a CI pipeline. If we are, we're going to set our null protect registry storage, or null protect I settings protect interface implementation. And this will prevent us from using the DAPI, which will give us access exceptions. Um, and then if we have a configuration, we're going to go and store that configuration off. And then we'll set, our settings instead. And then we kind of do the reverse on teardown. We'll go ahead and we'll take all the stored settings and set them back on the settings to get them saved. Um, and then we can also reset our settings. This is something that gets called from the teardown or setup in some of our test fixtures. And then for the in pipeline, I'm just checking for a common, predefined CI environmental variable. So if something changes in our pipelines where we're hiding those environmental variables, we'll get breakage, and you'll have to come in and figure out how to fix that. Probably not going to happen because we're not able to use Docker containers. That's usually where this happens is, a Docker container in the Docker container or something won't have the environmentals passed around. Um, we also have an HTTP listener that allows us to find a handler for a request, so that we can, have like a mock GitLab API that the language server calls, so we can check the user agent string. And so this is the generic base class that can be used anywhere in the code for doing that. And it'll handle finding a free port, starting up the listener, processing incoming requests, and then this implements the iDisposable pattern. So the way to use this is to use a using statement around it, and then it'll clean up the resources automatically when the test is done. What is this? Oh yeah. So one of the things I'm doing here is I'm saying, hey, for trace messages, let's also display those in the console, as opposed to just like debug view. So the nice part about this is when you're running a test, in the test output, you can see like all the debug messages coming from around the app.
Very nice.
Okay, then we have the biggest set of tests is around the language server. And so like we have tests for the exponential backoff. I have an extension to split lines. We have a test for. And then we have a test for the process manager, the LS client manager, where the LS client itself has a lot of tests in it, which includes, yes, the user agent test. Here's an example of using the test HTTP listener, where we stick in this usings block, which makes sure it'll call the dispose method on it when we're done. And it'll clean up the listener. And this works by passing in a handler function we have defined here. And this will get called on any request to our listener will get, this method will get called. And all we're doing is pulling out the user agent right now and then sending back a 200 message. And then this allows us to test if the user agent string is being sent correctly by the language server, like if it includes our data from it. And then for the test, I'm just going to go ahead and ask for a completion, which is going to make sure that we call a GitLab API. And then I pass in when we start it up, I just set this to our listener URL, the GitLab URL that we're going to use. And then we just do a check for that. So I think this is pretty standard test code. We have text fixtures, set up and tear downs, and then we just have a bunch of tests for various aspects of these of things. I think at this point it's fairly comprehensive for what we're able to test. We actually go and get a code completion and make sure it comes back. This is the only one that could be a stability issue, just because the API could be unstable.
Right. That's one that I've seen fail, and or at least that name looks familiar. As far as the tests, and I was wondering if that was part of it, because I was thinking I was seeing more failures yesterday when it was having problems. The API, that is.
Yeah, and one of the stability issues we hit in here was, again, a race condition between did change and completion. And so I added in another delay here in the code that you would get automatically if it was in real use, because this would often fail because this didn't process first. Now, in the current version of language server, this wouldn't be a problem. This is only a problem in the version where it actually used the data we're sending in the did change event, in the change message. But I'll leave it in there because hopefully we'll go back to the proper way of doing things for that. So we have, I think the test should be fairly self-explanatory. I have the component and part of the name for all these process management stuff. And then we also have tests for settings. And that's it. We don't have any tests right now for the status bar because, hard to do. We don't have any for code suggestions because of the Visual Studio requirement. So that's about where we're at. All right. Let's see if we got through everything so far. Any trouble spots to be aware of?
Like,
The,
are there any there here be dragons comments?
yeah, I don't really think so in our code.
Okay,
Um, it seems like it's holding together pretty good. Um, you know, I think it'll be interesting to see what bugs come back from customers.
right. That's a
So,
big wild card.
but one place that dragons exist is in the Golang language server, which is supposed to be semantically versioned, and they do not actually do
Yeah,
that.
yeah.
So there could be some pretty big changes between versions. So you can't just straight upgrade and expect it all to work. Um, what I've started doing is looking through the MRs to try and understand what they've changed and what the impact is going to be on us. And some of those changes have caused, you know, quite a few times it breaks our stuff. We have to go back and change how we're doing things a little bit to work with whatever they've decided to do.
How
Um,
where is that Golang LSP version picked up at?
right now, it's a manual process to upgrade it because they're not doing semantic versioning
Right.
properly.
So where's that at? Or like
So
how would we go about doing that?
yeah, so if you go to the main Microsoft Visual Studio IDE support for code suggestions epic, I have a whole bunch of pointers to other projects under the resources.
Okay.
And one of those is language server experiment. Here, I can switch over to my browser. Do, do, do. So here's the main epic that then has the sub epic for beta and experiment on it. And so here's the model gateway. Here's the language server experiment. So if we open that, and then they put them in as releases.
Hmm.
So you can go look and see what the current release is, which is 13. And then I just go and look at, um, I'll go and look at the MRs.
And is that picked up? I mean that's like defined in our code which one we're gonna get, right?
We have it checked in. So upgrading would be you'd have to download the most recent version, and then add it into the resources folder with the name what we're using, which is a little different from their published name.
Okay.
Um, and then merge the MR after
Gotcha.
we've run tests and verified it
Sure.
doesn't break everything.
Yeah, absolutely. Absolutely. Um, and I mean, and that's like generally the process that you're going through yourself.
Yeah.
And then like if you were gonna make a change to the LSP yourself, like I mean you did that, right? Like
Mhm.
you fixed some stuff, you would like compile that locally yourself and then point the Visual Studio extension to it or bundle it in or whatever, right?
Yeah. So for
You test that
local
out,
changes, what
develop.
I
Yeah.
do is, yeah, I clone the repository. Um, Usually I create an issue, and so I can use the issue number and the branch name. I
Sure.
have Golang installed on Windows, and then I edit the code usually using Visual Studio Code, compile it, and then I'll copy the output binary over to our resources folder, and then Control F5 to run that version.
Gotcha. Gotcha. Uh, yeah, yep. This is in the recording, so I will. That seems like something I'll probably try to add towards to the documentation too. Uh,
Yeah, and
which I guess that'll
if
be
you think you might,
temporary.
yeah, if you think you might be in here, I can do a brief walkthrough of the code. Um, so I don't know if
So I mean, yeah, I mean, I don't want to take up your time with something that I might not need. And there will be people that are here still that can hopefully help me out if need be, right?
Yeah, there's not a lot of code here, so it's not
That's
super
good. That's good.
hard.
That's good.
Um, package is going to have, so this is the how they actually, when they actually call an API, this provider is an abstraction over that client. Um, server, everything you're probably going to want to look at is in serve, and they're using they're using protocol 316. This is the one version back from current right now. This is how you'd find the protocol version we're working with. And then, in terms of where they handle stuff, it's all right here. So this is our start method. Just real quick. Here's like the initialize message that gets handled. And then, so anytime we see this handler dot stuff, this is where they're setting up stuff. So here's text document completion, text document did open, did change, did save, did close. You can see that most of these things aren't doing anything.
Yeah, yeah,
Really right now, all of it's in completion. And if you dig into this, you'll find that they're reading the file off disk and passing that on, as opposed to using the stuff that comes in through did change, which isn't really getting used now. I mean, they do call this refresh diagnostics thing, but if you go down the provider rabbit hole, you'll find that they're like here they remove the file ://. So this is a real path they're passing in, and then this does a file read on it under the curtains to get the data. So this is if you had to look at see how they're doing something, you'd look. This is where you'd look to see like what they're doing. Like we can look at the did change, and we can see that they're we would be able to understand that they're expecting the full file, not just a incremental change
yeah.
stuff. So that's just the 30-second walkthrough there. Um, yeah. All right. Let's see where we are.
Oh, right. That's where the dragons might be. That's why we got on that.
Yeah,
Just
yeah.
just backing up the conversation in my head.
Suggestions what I should or should not work on while you're gone. I would not work on dependency injection. Um, the reason I would say that is, I've kind of got a design in my head. This is like core architecture stuff. So if you haven't really done a lot of dependency injection architecture and you're not super familiar with how the code works, I'd say this would be a harder thing for you to do, or
I
a
think that
higher
sounds
risk of
right.
me coming back and going like, "What have you done?"
Yeah, 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 for sure, for sure, for sure.
um, but like I think that the things you could work on would be like supporting multiple code suggestions and prep for the language server changes. That's not a huge change. That's a get your feet wet in the code base change.
Yeah,
Um,
yeah.
I'll update the options description before I leave. Um, um, testing if that secondary extension control would conflict. Testing with resharper enabled. You can get a 30-day trial for that and see if there was an interaction. Anything that's kind of like I would say that anything that's kind of got a you know simple scope and isn't going to change a huge amount of stuff would be totally reasonable for you to work on. So if we get bugs that come in,
Yeah,
I would
yeah. I mean,
expect you to be able
bugs,
to investigate that and work on
bugs,
that too.
bugs. I assume is kind of a given that I'll like at least look into the
Yeah,
bugs and like this is super hard. I don't know what's going on here or whatever.
yeah.
At least a swag on an estimate. I- so uh, the we're working on a JetBrains LSP as well. Is that do you know is that going to be for all of the JetBrains products, or is it just
It should,
IntelliJ?
yeah. I think it should. Yeah, I think that all of their products are basically IntelliJ with some modifications. So I think all the IntelliJ extensions work for like PyCharm and Writer and whatever else is out there.
Um, Okay. I was just thinking through the scenario where like someone has ReSharper and they have Visual Studio running at the same time. And if there would be some weird code suggestions conflict from the GitLab side.
Oh, if they have, if you're using like a IntelliJ IDE and Visual Studio at the same time.
Well, I was thinking just the ReSharper plugin.
Hmm. Yeah, we should test that. I'm not sure if it does, if it used ghost text or not, ReSharper ever. But yeah, I think it's something that you can go ahead and test just by getting the demo version.
And I guess yeah, since I'm not super familiar with all the other editors, like IntelliJ is a full-blown editor, right? Like if you're going to do
Yeah, it's an
Java,
IDE.
right? By JetBrains, and then ReSharper is just a plugin for Visual Studio. So okay, yeah, less likely of a conflict.
Yeah, and then there's also a C# IDE from JetBrains called Writer. That's basically like they're like Microsoft wasn't making enough room for them, and because of how Microsoft had done some of their changes, like the plugin caused speed slowdowns in Visual Studio, and so I think they just went and wrote their own IDE, iterated off of IntelliJ. So it's the similar thing as the Golang version or the PHP version or the Python version of IntelliJ. It's just IntelliJ with sprinkles for that stuff. Um,
That's a whole interesting topic, I suppose, like why they
yeah,
need to be separate editors, but that's outside of scope of this talk.
yeah, I think that's how their code works. There's
Yeah,
enough special things for Java and IntelliJ that to have a good experience for, because like the experience of the VS Code having all these things jumbled into one, it's not really that great. Like, I would never use it for Java or C# development. It's just
sure,
ridiculous.
sure. Hmm.
Um,
Sorry,
yeah,
do you think that's what most C# developers share that sentiment? Like they're like, give me Visual Studio for C# dev.
yeah, yeah. I don't know why you would not use Visual Studio unless you're using Writer. That's kind of your two options is like you can get away with using VS Code, um, and maybe people are. I don't find it a very good experience because it's not nearly as feature packed um, as Visual Studio is. So I would expect people doing C# coding all day to use Visual Studio or Writer.
That that's that's amusing to me, to be honest. But so I mean, I guess like as long as there's C#, there's going to be Visual Studio.
Until VS Code gets enough functionality in it that you don't need it. I think that's a long ways off, though. It seems to be a long ways off. Like you can't navigate code easily, which is not very nice. But I think that's more because they're really pushing on like Python and TypeScript stuff that they don't have another editor for. Like there is a plugin for Visual Studio to add Python support, but I would just use VS Code these days for that.
Yeah.
It's a nicer
Yeah.
experience. Um,
Hmm.
yeah. So the last thing on our list is talking about debugging. And I guess the big question there is, did you get debug viewer working?
Yeah, I did. It, it, let's see. It would just like the log messages that were showing up were in like a slightly different format. Um, um, so like I was able to see like where you were sending stuff like you had deliberately sent like the name of the method, syntax, document did change async, and like a little bit of info about it. But then it looked like there were others um, that weren't. I couldn't find where they were like written.
Mm.
Um, is that coming from somewhere else besides our code? I guess is
Um, so you need to have a filter set with the, this will change with the new logging I'm doing. There'll be one prefix that we can filter on. Um, So like here's what the new version looks like. So in the new version, you can see all these messages start with GLVS EXT. And so my filter is now, simplified into this.
Yeah.
In the older version, though, you need to have LS client, and proposal source.
Yep. That's the filter that you had suggested somewhere that I did.
Yeah.
I put in. But
So, and then each of these are different components. So LS is for the license server manager stuff, and it will include all the console output from the language server. So for example, here we have a starting message. Here we're starting a language server instance. Here's our connection happening. And then this is the process identifier, and this is the console output from the license server itself.
the license server or language server?
Sorry, I
Okay.
don't know what it is, but I constantly say license
No,
server
I know
instead of language server.
it's yeah, no problem. I just okay, so this is an example of something that we're not output, like you're not driving this output here. It's somebody, it's the language server doing
Right.
this. Yeah,
This
okay.
this
Okay.
portion here is, yeah. And
Okay.
so
That makes me feel better.
interleaved, yeah. So interleaved with some of this, it's like you'll see us do. Here's a completion async call, and then here's the output from the language server as it does that. Like, and so we can see what it is, the before and after text. We can see if there's an error or if we got provided the message. Show me the full line. You can also copy messages out of this into an editor. There's some weird
Yeah.
try and
Yeah.
pop up the full line. We can see that stuff. Um, and then you can see that, we have buffer changes happening. We're calling out. And then not getting anything message back. It used to be when we did one of these changes, would get a log entry saying update context. But now those have gone away because now the update context is just reading the file off disk as opposed to using the data we send them, which is super annoying. And so on. So, and then there's also like, if you see a line that doesn't have a debug statement in it with the new logging system, it means we're actually using trace. And so like in the log, in this VS output, this is the logger, um, us trying to start up the pane to display stuff. And we don't have a logging system yet. So we're just using the trace call, and I put this prefix in there. So you'll see a few that are just like raw traces that will come out based on where they're at. But I'm going back and trying to be better about putting the full like function path name in, construction arguments if they make sense, or arguments to the method that make sense, and so on. I've been expanding the logging quite a bit to try and make it so that it'll, because once we get some from the customer, we don't want to do like, oh, let's publish a new extension to add some more
Right.
logging.
Yeah, absolutely.
So
Yeah, I
I'm
know that
trying to be,
dance.
yeah. So I'm trying to be looking forward on adding quite a bit of trace messages around, um, so that we could see the code flow from the logs, which would give us a sense if there's an exception that we aren't catching correctly or something weird is happening. We should be able to see that in the logs.
Um, and this is something like if I had to work with the customer to debug something, we would have them install this program and like give us the logs. Is
Nope.
that no?
No, because here, let me show you how this works. Because it's pretty slick now. How I've gotten it. So in the release version, this trace log is not available. If they install debug view, they wouldn't see anything. Um, Instead, I'm just starting up a quick instance of Visual Studio here to show you. Instead, we're going to display things to the output window to a custom pane. And so the user would just be able to copy and paste out of Visual Studio to provide
This
us
is
the
with the
data.
changes that you have in progress right now.
Right, right,
Yeah.
right.
Okay. Okay.
Yeah, right this second, yes, they would have to get the debug viewer to get the error messages, but
Gotcha. Gotcha.
today
Yeah.
or
Yeah.
tomorrow,
Yep.
that's going to change.
Yep. Yep. Awesome.
Are you starting Visual Studio? Oh, you did. It's not foregrounded. It's here in our output window drop down, we have GitLab extension, and here's all the messages going to it.
Nice. Nice. Which is basically the same stuff that we were looking at in debug view.
Yep. So we do code suggestion, we get more and more lovely stuff happening.
Nice.
So yeah, so once this update rolls out, we can just have them go to this output pane and copy paste it all over to
That
it.
seems kind of handy for us too, as we're
Um,
developing.
yeah, I still prefer using the debug view when I'm developing. This would be where this will be nice is you're running Visual Studio to do your dev, and you'll have the log output from that in a window that you can see separately from the debug viewer. So, I install the release version of the extensions in my main Visual Studio, and that will not log to debug viewer. And then when I'm starting a secondary instance to test out a change, I can see all that. I can be monitoring that in my debug viewer window, as opposed to having to go over and start the extension thing and so on. I just find that it's just easier for me. I have I have a docking system on my Windows, so I have my debug viewer docked at the top my screen, and then my instance that's
Mhm.
under investigation or testing is the bottom half of my screen. So I can just see all the messages scroll by while I'm doing stuff. Makes it really easy for me.
Nice.
But yeah, you could definitely use it that way. Um, the big reason that we were doing this is to try and make it seem more similar to the VS Code experience.
Okay.
Because VS Code has a common window you can put all your messages in, um, which is how VS Code is doing their stuff. And the PM really wanted us to try and mimic that as much as possible. And I
Gotcha.
think there were some, concerns about writing data to disk. Originally I was going to have just a stash setting where it's like enable debug log to disk. Here's the file name. Um, but I got a lot of pushback. I think there were some worries about, accidentally logging stuff to disk that would be sensitive. Although I don't
Sure.
really understand that because everything that we're sending back and forth is their code files that are already on disk. And my guess is that these output windows are, when they get big enough, are buffered to disk. Um, you can imagine if I'm coding for like 4 hour session, this log is going to get huge, you know.
Yeah. Yeah. Yeah.
And I
Yeah. Yeah. Yeah.
imagine they're not just going to keep that all in memory. There's got to be a way that they cache it to disk. Um, so I feel like the log is probably going to be on disk if you knew where to look, anyways. And that's one of the reasons I'm trying to take some extra work to make sure we're, um, masking out things like the personal access token
Yeah. Yeah.
things. All right.
Uh,
And then,
yeah.
do you have any other questions about debugging?
No, no, that was helpful. And was good to confirm what I was thinking maybe was happening, about us not writing all those messages from our extension. So
Yeah.
very good.
Oh,
Yeah.
well, I think we've gone through your list. Is there anything else that you'd want to talk about?
Uh, Definitely not on recording.
All right, I'll end the recording.
Goodbye, viewers.